Good evening, my 11th standard warriors. It's time to start and spin in circular motion with me, Shreyas, your physics master teacher at Vedantu, going live. Hello, my warriors. Hi, Molesh, Madhurima, Roshni, kaise ho? Hi, hi, Muskan. Hi, Saja. Hi, Suchi Mama. Hello, Anil Kumar. Hello, Pathuri. Welcome, Samozi. Hello, Ankit. Long time. Hi, Spreet. Nice to see you back. Hello Ashika, good evening my lovely warriors, this is Shreyas here, your captain for this channel and your physics master teacher leading the physics department at Vedantu, teaching kids, training kids for a very long time and having mentored these thousands and thousands of kids, I know what it takes to enter into the topmost premier colleges because many of my students are right now in IITs, NITs, BITS, and in fact some of them have even graduated from that. So if you want to get there and then you want good ranks, you want good branch, please follow this channel, hit the subscribe button right now, and also do not forget to show your love and support by smashing the like button down there so that you can regularly follow me. YouTube will recommend my videos to you guys on regular basis. And welcome to the Nurture series, which is a 11th standard series, long-term series, and we are right now in circular motion. We have already completed basic maths, units and dimensions, vectors, 1D, 2D, relative, Newton's laws, friction, work power energy, and right now we are in circular. After this we'll go to center of mass, then momentum, and then rotation and system of particles. Gravitation will start probably after November Mangalam, but if you are in urgent need of gravitation, there is a flash series which I had conducted last year, so you can watch that last year's class if there is an urgent need, otherwise wait for some time. In Vedantu, you know, there are lot of toppers which you might not know, and you know, people have not just excelled, the students have not just, you know, aced in JEE mains, but they have also aced in, you know, the board examination or CET examination, and we are just awaiting our JEE advanced results. I am pretty sure they would have nailed it. The topmost rank from Vedantu this year was All India rank 35 from JEE mains, and there are more than 900 students who have got below 10,000 rank in JEE mains. That's a massive ratio. Imagine out of 10,000 students, 900 students just from Vedantu, and you take any board toppers or you take any merit list, you will find Vedans everywhere. So Vedantu clearly is making a difference. That means our teachers, our ecosystem, our assignments, our, you know, slides, our methodologies, our tests are definitely working. And if you want to be a part of this online revolution, please check out the link which is there in the description box, because the batches for the long term will start on Monday. Not just that, there are crash courses available for CBSE, for JEE, for NEET, depending on whatever you need. And all the syllabus will be covered, the proper classes like you would expect. So I know your schools have started and you need some coaching. Maybe you are finding it difficult at school. Maybe you are not able to manage time between school and, you know, studies. So you need some help. So please take that help, because the courses are as low as, you know, 3,600 rupees per month, and you get 10% off using my coupon code SHHPRO. There are 3 versions, so depending on what features you want. So this is the most advanced feature, the plus. In light you get all the basic requirements. Most of the students go for the classic version. Some students go for the plus version as well. Okay, so having said that, please do not also forget to join our Telegram group. There is a link in the description box below. So let's start with circular motion. Now, in case of translation, right? Just one second. Yeah. In case of translation, you talk about position. So let's say there is some person here on the x-axis. You always are worried about the position. X refers to the position of that particle. This chapter is all about circular motion. In circular motion, that particle will be moving in a circle. So if I talk about the x and the y coordinates of the particle, you know, both the y as well as the x coordinate will continuously keep changing. It will become little bit difficult to analyze the motion in terms of y and x. Hence, we define a new system to measure or to locate that particle. And that method is basically called as the polar method or the polar coordinates. In general, see guys, whenever you have this as the x-axis, this is y-axis, if there is a particle in 2D, then you always have the y coordinate and you have the x coordinate, correct? So x and y coordinates give you the position of a particle in 2D plane. But because we know the particle is going in a circle, it makes sense to change our coordinate system and we use something called as the polar coordinates. So what are these polar coordinates? It's very simple. Look at this. Imagine there is a particle which is going in a circle, okay, and let's say the radius is r. So this is r and I take one line as my reference line. Let's say this is my reference, okay, this is my reference line, okay, or reference axis. With respect to the reference line, how much angle I have covered? That is theta. That theta is called as your angular position. Theta is angular position, r is the distance from your origin. These two variables are called as your polar coordinates, r and theta, radius and theta. Why is it better to use r theta over x and y? Because when the particle goes in the circle, it's very easy to tell, oh, the particle's distance from the center is r meters and it is at 30 degrees, it is at 50 degrees, it is at 70, it is at 90, it is at 180. So it becomes easier to locate the particle in terms of angle and the distance from the origin. And the speciality of circular motion is that in a circular motion, r will remain constant, so it becomes easy. Is that making sense? I hope that is clear. I hope that is clear. So basically in circular motion, theta will keep on changing and that theta which it makes with the reference line is called as angular position. So the angle made by the position vector, this is the vector which is the position vector of that particle, okay, of a moving particle with respect to the origin, with respect to the reference line, is called as the angular position. As simple as that. Now, if everybody is okay till this point, what will happen when the particle moves? Obviously, when the particle moves, you can see that there is some displacement. That's right. That's angular displacement. Just like when a particle moves from here to here, you have just the displacement, which is s, which is delta x. Okay, this is linear or translation displacement. Angular displacement is how much angle I moved. I was here initially. Now I am here at some time t. This is the angle which I have displaced, not this one. This is not angular displacement. This is just displacement. This is angular displacement. And the symbol for that is delta theta. What is it? Delta theta. Theta tells you current position. Delta theta tells you change in the position. So it was here, now it is here. This is the change. Hence, the angular displacement is nothing but change in angular position. As simple as that. And the symbol for that is delta theta. S is the actual displacement, and you can see for small angles, okay, for small angles, this displacement will be the length of the arc. Can you see that? That displacement will be the length of the arc. This is for small delta theta. Can you see that? That arc length and that straight line will be same. Yes, delta means change. Correcto. Delta means change always. Yep, that's right. Hi Jayaditya, welcome aboard. And what is the formula for length of the arc? It is always radius times of the angle subtended. In this case, it is delta theta. So S is r theta. As simple as that. You can also write del theta is S by R. One and the same thing. This is straight away the formula for, length of the arc. Length of the arc is R into theta. Remember, this theta has to be in radians, not in degrees, okay? If you put it in degrees, be careful, you have to multiply it and divide it this by, 2 pi and 360 and all of that. Yeah, very good. You studied this formula in maths. Correcto. Beautiful. Great. Now, moving on to the next concept. So, quickly seeing the formulas and the theory. The angular displacement is the angle subtended by the position at the center of a circular path. So, this is the angle subtended by the angular displacement is del S by R. And this is the displacement. Okay, that is R delta theta. It is one and the same thing. You shift R over there. S is R theta, where delta S, I think that delta S was missing here. Delta S is the linear displacement and R is the radius. Okay, so that delta S was missing over here, where delta S is the linear displacement and R is the radius. Unit is obviously radians, because most of the times you will see in maths and physics you will always measure angles in radians. Okay, now let's go to the next thing. This will give you a deja vu of your probably initial months at Vedantu or whichever coaching you are studying in. We start with position, then displacement, then velocity, then acceleration. So guys, exactly the same things over here. Now the next term will be angular velocity. You have something, okay, a particle, a point or any object, it moves from this point to this point. How quickly it moves from here to here, that is angular velocity. How much angle it covers per unit time, that is angular velocity. I hope this is clear. Yep. So imagine, you can think of, oh by the way, this was a cool simulation, a slide of the turbine of an aeroplane. This looks really cool. So just imagine some point which is moving along that circumference, something like this. So what is this angular velocity? It's basically angle covered or displaced, okay, or displaced, okay, displaced. The whole thing divided by time taken. It's time taken. Now what is the symbol for velocity? Usually it was V. That was for linear velocity. But angular velocity, the symbol is omega, and displacement is delta theta. Time interval or time taken is delta t. So this is angular velocity, guys. Obviously you can see the numerator is in radians and denominator is in seconds. So radians per second, as simple as that. Okay, very easy. Now I'll show you one very interesting thing. See, if I tell you that this line over here is nothing but displacement, correct? If this line is displacement, think, just some time back I told you that displacement is nothing but radius times the angle theta, or delta theta, which is the angular displacement. Length of the arc is r theta, right? How about dividing both sides with time, both sides with the time interval? How much time it takes to go from here to here? See what will happen, guys. Very interesting thing. On the RHS, del theta by del t, that is nothing but angular velocity, correct? That is nothing but angular velocity. What is S by t? Displacement by time is not angular velocity, it is just linear or translatory velocity. So V is r omega. Very important. Very interesting relationship which we just derived. Isn't it interesting? I hope this is clear. I hope this is clear. Yep. So the idea behind angular velocity is how much angle you cover per unit time. You can also write it as r omega. Now I'll tell you the importance of this relationship. Just imagine if you have a fan, okay, like this, and let's say the blades are rotating like this. I'm just considering one blade. If I take 2 points A and B, which one do you think has more omega? Which point on these two blades, which point on this blade do you think has more omega, A or B? A is more than B or both are equal? Think about it and let me know. Very good. Understood O, clear O, excelente. Most of you are saying B. Acha. Kritik, just do one thing, just close the browser, open it again, refresh it, it should work. Try Chrome browser, most likely it should work. Okay, sometimes there might be problem. Well, very good Salva Kumar, both are same, correcto. In fact, both are same because think about it, you guys made a mistake. When it comes over here, this guy and this guy both have covered the same angle. They both cover the same angle in the same time. This goes here, this goes here. So angular velocity is same. But you know what is different? The linear velocity is different. The velocity of A is less than velocity of B because R is more, V is R omega. Omega is same. R is more for B. So bigger the radius or farther the distance, it will have to move faster to cover the same angle. So the one on the edge, the one far away from the axis will have to move with a faster speed to cover the same angle on a body. I hope this is clear. Yep. Is this clear? Very good crack with Gokulnath. Okay, so this is your favorite chapter. I hope you'll enjoy this for sure. So very, very interesting thing. Now the next concept over here. Okay, so now that you guys have understood what is this linear velocity and what is this angular velocity, yeah, the next concept over here is angular velocity's direction. Okay, angular velocity can also be, represented in vector form, and the direction of omega can be found out by right hand thumb rule. Use right hand thumb rule. So what is this right hand thumb rule? You curl your fingers, okay, you curl your fingers in the sense of rotation, as in how is it rotating? Your thumb, okay, your thumb of the hand will point in the direction of omega, okay, your thumb will point in the direction of omega. Like over here, if you curl your fingers like this, you will see the thumb will go here. So basically, in 3 dimension, this is the direction of omega vector. It will be perpendicular to this disk's plane. See this if it is clear. Okay, that's how it is. Yep. So omega is V by R. No. V is omega R, guys. So omega is V by R, but where is this? Just oh my god, omega is V by R. Understand in that what you are mistaking is that R is different, omega is same. Understand this. V will be different, R will be different, but V and R, both the numerator and denominator will increase and decrease by the same amount, so the ratio will be constant, bacha. Yeah. Okay. So now if I ask you, guys, come on, quickly tell me what is the direction of omega for my hand. Okay, I'm rotating my hand. Quickly tell me where is angular velocity of my hand. Come on, everybody use your right hand thumb rule. Curl your fingers in the direction in which I'm rotating my hand. Move your hand, right hand only, and see where your thumb is pointing towards. Is the thumb pointing up, down, in, out, left, right? Think about it. Towards the board says Hirak. Okay, interesting. Yep, let's see how many of you get it. Towards the board. Yeah, so guys, you just have to curl your fingers like this. It goes inside like this. Correcto, perfect. You guys have understood right hand thumb rule. Now if you quickly look at the direction of R, V and omega, you can also guess this equation is actually a vector equation. This was in scalar form. In vector form, you can write it in vector form as well, and V vector will be something cross something. It will be either R cross omega or omega cross R. Again, use your right hand rule, cross product, and see which one should be correct. Is it R cross omega or is it omega cross R? Come on, my warriors, figure this out. R vector will be here. This is my position vector. Velocity vector is there. Okay, don't look at this green arrow like that, think of it as if it is going inside. Think as if the velocity is in, radius vector is there. So R cross V, or is it V cross R? Okay, come on. Sorry, R cross omega, my bad. Is it R cross omega gives you V, or omega cross R gives you V? Think about it. R is here, omega is there. So if you do R cross omega, it will come this way. R cross omega comes this way. But if you turn your hand like this and first point towards omega and then go towards R, then it goes inside, which is actually the direction of the velocity. It goes there. So hence, guys, it should be omega cross R. That's what the vector formula is. It's not R cross omega. Be careful, guys. It is not R cross omega. It is omega cross R. Yep. So keep this in mind. Omega vector is this way. R vector is like that. Point it inwards. See this. This was going like this. Angular velocity was up. Omega cross R. You will see the thumb goes inside. That's where the velocity is directed. I hope that is clear. Yeah. Is that clear, everyone, my warriors? The slide is very important. You can probably take a screenshot of this. Very, very important slide for all of you. Excellent. Let's move on. Yep. So all the important points, whatever I told you, is there over here. Angular velocity is del theta by del t. V is omega cross R. Most important takeaways. Whatever I told you is mentioned as notes for, later reference. It will be available to you in the PDF, which will be shared on our Telegram channel as well. Now, just like you have average velocity, you will also have instantaneous velocity. Same thing in circular motion. Average omega was del theta by del t. This was a large interval. This was a large displacement. Instantaneous omega will be small time interval and the small angle covered. As simple as that. So if this is time t and this is t plus dt, then this angle might be very small. So it is d theta. So that is the instantaneous. At that instant, what is your angular velocity? Okay. It is possible that the particle might be moving with some velocity, then suddenly increases velocity, then decreases, then increases, then decreases. Anything could happen, right? So at every instant, it might cover different angles. Maybe now it covered this much. Okay, it covered this much. After some time, it covers this much. Then it covers this much. Then it covers this much. And again, it covers this much. Again, it covers this much. And again, it covers this much. Obviously, every instant, the angular velocity could be different. So that is instantaneous angular velocity, as simple as that. At instant, what is your angle covered per unit time? D theta by dt. And if you are very well versed, or if you have been attending my classes, you know this d and d do not get cancelled. They are derivatives. This stands also for rate of change of any quantity. So that's what it is. Okay, let's see how many of you can quickly guess what should be the next title over here. We talked about angular position, we talked about angular displacement, we talked about angular velocity and its instantaneous value. What should be the next thing that we should talk about? Yeah, perfecto, Salva Kumar. We should talk about angular acceleration. Let's accelerate, guys. Yeah, this is how angular acceleration looks like. That wheel's velocity keeps increasing. The angular velocity keeps changing. So that is angular acceleration. Correcto. So what is angular acceleration? To put it very bluntly and straightforward, it is nothing but how much is the change in angular velocity upon the time taken. So my angular acceleration, by the way, the symbol for that is alpha. Okay, it's not a, it's alpha. Just like you had a is delta v by delta t, here you have alpha is equal to delta omega by delta t. This is the formula. Unit, you can guess it. This is radian per second by second. That means second square. Try to see the resemblance. In translation, it used to be meter per second square. Instead of meter, you have radian, so radian per second square, as simple as that. Okay, again, one interesting thing, V was omega r. How about differentiating? Just try to find out dV by dt. dV by dt, omega is, let's say, not going to be constant, because if velocity changes, if my speed changes, omega will also change. Radius will be constant, so r is outside. It will be d omega by dt. Now, what is d omega by dt? D omega by dt is nothing but alpha. This is r, and dv by dt is acceleration. So, this formula gives me the acceleration of that particle along that line which it is traveling. So let's say here it has some velocity v. After some time, okay, it has some velocity v plus dv. This was, let's say, at some time t. This was at some time t plus dt. So definitely it has some linear, this is linear or tangential, because it is along the tangent, right? Tangential acceleration, and that is r alpha. As simple as that. Very good, very good. It is tangential acceleration. Very good, very good, excellent. Please cover the syllabus fast. Yes, I'll do that. I'll complete all the syllabus very fast. Don't worry, bacha. We'll be done by January or something, January, February. Okay, 11th standard. Very good. Chalo, let's get moving to the next one. So, one important thing, I'll explain you this diagram also. Okay, by the way, just like you had average acceleration and instantaneous acceleration, same concept is there over here as well. So, average alpha will be del omega by del t, but instantaneous alpha will be d omega by dt. So that's obvious, like difference between instantaneous and average. Now let's talk about this diagram. Okay, let's talk about what this figure actually represents. Very, very interesting. Just imagine, okay, your hand and you move it like this. Okay, you're moving it like this. So if you're moving it like this, then let's just say, okay, if you're moving this like this, then if you want to find where is omega, so curl your fingers in the direction, you will see the thumb will point upwards, so omega is upwards. Where is omega? Omega is upwards. You can see that it's going like this. Okay, now if angular acceleration, angle wise, it accelerates exactly the same way. It accelerates in the same way as the omega is. So omega and alpha, if they are in the same direction, what will happen? The speed of the particle will increase. That's what will happen. That's right. Omega and alpha, if they are in the same direction, the speed will increase. But if the particle is rotating like this, okay, if the particle's omega is upwards like this and alpha is down, look at how your fingers curl like that. So your object is trying to rotate like that, but your acceleration is backwards. It's opposite to how it tries to move. So it's going to retard, it's going to slow down. So that's very important. If omega and alpha in the same direction, it accelerates. If omega and alpha in the opposite direction, it retards, it decelerates. Correct. Very good. Now, how do you find the direction of alpha? Salva Kumar, same rule, right hand thumb rule. Is the speed increasing or decreasing? Just check that out. If it is increasing, same as omega. If it is decreasing, opposite to omega, bacha. As simple as that. And if it is not changing, if omega is constant, then alpha is 0. Okay, I hope that makes sense. Okay, so from where alpha created, so it's just like a symbol. From where is A created? Okay, now how can, if you're talking from physics perspective, how is angular acceleration created? That is created by torque, and we will be talking about torque in rotation. You need to apply a torque to create angular acceleration. Without torque, you will not have angular acceleration. Okay, chalo, let's do some questions coming up on the screen. And I just spoke about instantaneous angular acceleration as well, d omega by dt. Okay, so the first question coming up on your screen now. Great, great, great. The angular velocity of the hour's hand in a wall clock. So you have three hands, the minute, the second, and the hour hand. So for an hour hand, how much is the angular velocity in radians per second? Come on, my warriors. Come on, come on, come on. Let's see. Perfecto. Paulami, you should too attend, irrespective of whether Aishwarya attends or not. You should attend. Alright, I would love to have all the warriors out here on every class, live, making new friends, motivating others, calling your friends as well. Sir, please cover the syllabus fast, like I just said. Yes, bacha, I am going to cover the syllabus by January or February. Yeah, so hold on, chill. We have a lot of time. You are just entered into 11th standard, right? So it's going to take some time. Your board examinations ended, like the results were announced in like hardly few months back. So everything has been delayed because of COVID, you know that. How much time does it rotate? You have to figure that out, bacha. So, well, this is 12. Okay, this is 6. So, you know, for an hour hand, alright, for an hour hand to complete one rotation, how much time does it take? Obviously 12 hours, correct? So, hour hand takes 12 hours to rotate. Obviously, and what is the question? Angular velocity. Omega is del theta by del t. Okay. How much is the angle covered? The angle covered is 360, which is 2 pi radian. Time taken. The time taken is 12 hours. This was radian, this is hours, but I don't want hours. But before that, let me just divide this by 6. So this will be radian, but per hour. So convert it into seconds. So pi divided by 1 hour is 60 minutes. And each minute is 60 seconds. So now this will be radian per second. 666 will become 216. So this will become 216 and those two zeros. So 2 zeros. So it will become radians per second. And is that there? Yep, it is there. Option C. Perfecto. How many of you got it, guys? Please tell me. Excellente, Dakshin. Excellente. Lovely, my warriors. Very good crack at Gopalnath. Very good, Salvakumar. Finally, you guys got it. Yes, that's the answer. So, very simple. Moving on to the next one. Let's see if we can get this. A point on the rim of a wheel 2 meters in diameter has a linear or tangential acceleration of 8 meters per second square. The question is, what is the angular acceleration of the wheel? Try and recollect the formula, you will get it. Yes, see, bacha, we will be covering it at the same pace, just that we'll be covering it earlier next year because the pandemic effect would have probably faded away. Yes, that's what will happen. Okay. So I don't want to hurry up the syllabus just because everything started late, and it's not that you have to complete it by December, right? Doesn't make sense. Okay, because if it was usual time, then yes, I would have completed it by December, but we have to extend it by 1 or 2 months. Okay, so Saja is asking, cover the syllabus ACP. Okay, Saja, sit tomorrow, I'll complete entire syllabus within 24 hours. From morning till night, I'll take classes, I'll cover everything. Nothing will enter your head. Okay, have fun. Okay, A, B, C. Interesting, guys. The answer is B. Many of you made a mistake in calculation. Okay, so remember the formula for tangential acceleration is alpha into r. Tangential acceleration is given to be 8. Alpha, I don't know. R is 1 because diameter is 2. Diameter is 2, that means the radius is 1. So be careful, alpha is 8. That is the answer, which is option B. Done, done, done. Most of you forgot to divide that diameter by 2 and you got a wrong answer. Next question coming up on your screen now. Chalo. Is it lecture 1? Yes, it is lecture 1, bacha. The angle turned by a body undergoing circular motion depends on the time. As a function of time, theta naught, some constant, theta 1 t plus theta 2 t square, some function of time. Then what is the angular acceleration of the body instantaneous? So the question is basically find alpha, you know, it will be some function maybe of time, hopefully. Let's see. How many of you can get this? Hello NK Arts, welcome aboard. Oh my god, Selva Kumar, every time I've seen many students always do that common mistake, diameter radius. Forget to either multiply or divide by 2. So be careful. Now next time you should not do this. Okay, so quickly use the derivatives concept and I'm pretty sure you will be able to get it. It's just like solving your normal translation problem. If position is known, you want to find acceleration, first find velocity. That's what you need to do. So theta is given. From theta, what will you do? You will find omega, which is d theta by dt. The derivative of theta naught plus theta 1t plus theta 2t square. What will it give you? Constant's derivative 0. This guy's derivative theta 1 into 1 because t's derivative is 1 plus theta 2 into t square's derivative. Use x raised to n formula. X is t, n is 2. So 2 comes outside. 2 minus 1 is 1. So into t. So this will become theta 1 plus theta 2. 2 into t. That is your omega. Now that's not the question. The question is angular acceleration. Alpha will be d omega by dt. That means it is derivative of this term which is theta 1 plus 2 theta 2 into time. Acha. Theta 1 constant, derivative 0. 2 theta 2 constant, so it comes outside. Derivative of time 1. So basically the answer will be 2 theta 2. 2 theta 2 is over here. Option D. Done, done, guys. Everybody clear? Wow. So many of you have flooded the chat box. Excellent. Proud of you, my warriors. Thank you for flooding it. I'm proud of you. You guys have done it. Excellent. Looks like you guys have attended my derivatives class someday or the other. Okay. Proud of you. Now that we know about velocity, angular velocity, tangential acceleration, and angular acceleration and angular displacement, let's talk about some new kind of acceleration which you might have heard of. That is called as centripetal. Let me ask you one question. Just imagine there is a particle and it is turning. Imagine a particle and it is turning. If it turns, will that mean that the velocity is changing? If the particle turns, does that mean velocity is changing? Let's think. What is velocity? Velocity is a vector quantity. That means it has magnitude, it has direction. Now, if the particle's direction changes, obviously the vector will change. And if the vector changes, my dear warriors, obviously if the velocity changes, it should accelerate. So that acceleration, which is because of change in direction. I am moving like this. I suddenly turn. The moment I turn, that's it. I am accelerating. So that acceleration which results in changing of the direction is called centripetal acceleration. So what does centripetal acceleration do? It only changes direction. Okay, it only changes direction. It does not, okay, it doesn't affect the speed. Then you will be wondering, sir, is there some acceleration which will affect the speed? Think, did I teach you something? Is there some acceleration which can affect speed? I think I just showed you something just some time back. NCERT is important irrespective of JEE Advanced and Mains. You need to know your fundamentals before going to JEE Advanced. So in the end you don't need it, Shilpa, but in the basic or the starting part you will need it. Yep. So that acceleration which causes change in speed was tangential acceleration. Alpha, yes, the tangential one. Correct. So the tangential acceleration along the tangent that pulls that velocity. If that particle is moving like this, the velocity will get stretched. It will change the velocity along with the tangent. It pulls the length of that velocity, or it can compress it. So that causes angular acceleration or changes in speed. But the centripetal acceleration, no. This acceleration, like you can see, is directed, a centripetal is directed towards the center of the circle. That's why the name centripetal. Petal means towards the center. So centripetal. This blue one is nothing but your velocity. Okay, so that blue one was nothing but your velocity. So that is actually perpendicular, like you can see over here. Everybody fine about this? Okay. Now why does the center pull? You might be wondering. Perfect question, Suchi Mama. You should have this doubt. Why the hell should the center pull the particle? So remember, that is going to be taught in the next class, lecture 2. That's dynamics. That will amount to something called as the centripetal force. There is a force which will pull it towards the center. I'll be explaining it in this class 2. Yeah, it could be some kind of force. We'll be talking about it. Don't worry about it. Remember, when I started kinematics long time back, I told you kinematics is the study of how things are happening. Why it is being pulled? That is dynamics. Today we are studying kinematics. That means how it is moving, how it is accelerating, how much is the acceleration, why is it accelerating? That is the next that is the next class, next session. I hope this is clear. Everybody clear about this? Yes, tangential acceleration is also linear acceleration in a way. Yep. Dynamics means why things are happening, forces and collisions and all of that will be coming under dynamics. Okay, now there is a beautiful derivation for that. If you want, you can check out my derivation course in the pro subscription. I have explained in detail how it has been derived, but let me give you the formula, which is very important. So learn the application first. The centripetal acceleration formula comes out to be v square divided by the radius, v square by r. But just some time back I told you v is omega r, right? V was omega r. So if you want, you can substitute it and see what do you get. Okay, so if you just substitute that, you will get omega r whole square divided by r. Now you can see what will happen. You will see that it will become omega square r square by r. One of the r will get cancelled. So you have two forms, either this or you can use omega square r. It's up to you what is given in the question. Accordingly, you use either this formula or this formula, v square by r or omega square r, one and the same thing. Correct? Yes. This acceleration is always directed towards the center. That's why it is called centripetal, petal towards. This acceleration is always perpendicular to the velocity. So can it change the speed? No. Can it change the direction? Yes. If it changes direction, there is centripetal. If it does not change direction, okay guys, come on, think. If there is a particle moving in a straight line, it is moving in a straight line, will there be centripetal acceleration? Yes or no? Come on my warriors, think about it. Will there be centripetal acceleration? Obviously no, because direction is not changing. So centripetal will be 0. Will there be tangential? Maybe, if the speed is changing. So there will be no reason why there should be an acceleration perpendicular to the motion. That's what it is. So you can see the velocity is continuously changing the direction and there is a pull towards the center. So that is centripetal acceleration. Okay, so centripetal acceleration is v square by r or omega square r. Okay, so I will get this symbol edited. This should not be alpha. This was supposed to be just AC. Okay, a centripetal. That's what it is. Okay, it is also called as radial acceleration. The earlier one was tangential. Keep this in mind. Okay, let's see if you can get this question coming up on your screen right now. Come on my warriors. What is the magnitude of the centripetal acceleration of a car following a curve of radius 500 meters at the speed of 90 kilometers per hour? Let's visualize it. Meanwhile, you can start solving it. So there is a car and it's moving on a road. The road's radius is given how much? 500 meters. And I think the velocity also is given. How much it is? 90 kilometers per hour. 90 kilometers per hour will be 90 into 5 by 18 meters per second. So this will be 5 into 5. That's 25 meters per second. Correct? So that's the velocity. What's the question? The question is, what is the magnitude of the centripetal acceleration? What is the formula? Centripetal acceleration is v square by r or omega square r. Which formula will I use? This one or this one? Obviously, I don't know omega, I know V, so obviously I'll use this one. So what is V? V is 25 whole square divided by R, which is how much? 500. What is 25 square? That's 625. I think I can write this as 5 into 100 now, because then this will go as 125. So this will then become 1.25, that's centripetal meters per second square. That should be the answer. Is that clear? Oh wow, the screen is full. Excellent. Proud of you. Proud of you guys. Wow, very good. I'm so proud of you guys that you guys are giving the answers very quickly. Very good. 1.25 meters per second square. Moving to the next question, but before that, remember, if you have any doubts and you want to ask our doubt experts, take a picture or chat with our doubt experts. Unlimited number of questions on our doubt app. There is no limit on that, free of cost. Obviously, you should be a pro subscriber for that. And you can also send in your solutions and get it verified. Now moving on to something called as uniform circular motion. See, we have laid all the framework and we have done all that groundwork needed to study more and more concepts now. Let's talk about uniform circular motion. Now, you might have seen giant wheel. The motion of a giant wheel obviously is uniform circular motion. But what about the motion of the fan? That is also uniform circular motion most of the times. But when you start the fan or when you start the giant wheel, it is non-uniform circular motion. Why? Because when you start, you will see the velocity keeps increasing till it reaches a standard value and it starts moving with a constant velocity. So basically, uniform circular motion means it should cover same angle in same time. If it covers 10 degrees in 1 second, next 1 second 10, next 1 second 10 degrees, next 1 second 10 degrees. But if right now it is moving 10 degrees, next instant it moves 20, next instant it moves 5, next instant it moves 30, then that is non-uniform circular motion. That's what it is. Okay, so it increases or it decreases, something happens to the omega, that is non-uniform circular motion. Now the best part about uniform circular motion, like the one over here, it's beautifully, from that time it is bichara rotating, it neither stopped nor it accelerated. So the magnitude of the velocity, do you remember this magnitude of velocity, guys? What is it? Speed. So the speed of the particle remains constant. It is called uniform circular motion. Very good. So that's uniform circular motion. Next, very easy, guys. What is the meaning of time period? Time period. Time period means how much time it takes to come back to the same point. How much time, if I start here, how much time it takes to come back to the same point. If I take this point, how much time it takes to come back to this point. That is basically the time period. And there is a very important formula you should know for time period. Okay, I'll tell you what it is. See, what was omega? Omega was angle covered upon time taken, right? Angle covered upon time taken. For one rotation, what will be the time taken? Obviously, for one rotation, the time taken will be the time period. And what will be the angle covered? Obviously, the angle covered is 2 by radian, correct? That means what will be omega? It will be nothing but 2 pi by t. Very important formula. Very, very important formula. Omega is 2 pi by t. We can also write t as 2 pi by omega. One and the same thing. Okay, you can take t over there, omega below. Remember this, like keep saying it 100 times, you will remember it. Omega is 2 pi by t, t is 2 pi by omega, omega is v by r, v is omega r, ac is v square by r, ac is omega square r, v is omega r. You will be able to remember this after few days. I know initially everything looks jumbled. What's omega, r, ac, at, what the hell? Okay, it takes some time. Okay, so time period is 2 pi by omega. Great. Moving on to the next concept. Once you have time period, you should have frequency. You should have frequency. Yep, this sounds like a rap. Oh, please don't make a rap song out of it and don't make a meme. Okay, so what do we have next? Frequency. How many rounds per unit time? How many rounds per unit time? It rotates 5 times in 1 second. 5 hertz. It rotates 20 times in 1 second. 20 hertz. Hertz is the unit of frequency, which is 1 by second times per unit time. How many times it rotates? So it's basically the number of rotations in 1 second. 1 second is the unit of time. So that is frequency f. So f is 1 by t, standard formula. If it takes, just imagine this. Yep, if it takes only 0.1 second to complete one revolution, 0.1 second to complete one revolution, frequency will be 1 by 0.1, which is 10 hertz. Because in 0.1 second, one revolution, 0.1, 0.1, 0.1, 0.1, 0.1, 10 times it will rotate in 1 second. So frequency is 10 hertz. Simple. Done, done, done. Okay. You can also see why this omega will be 2 pi f. Why? What is the reason? Remember, omega was 2 pi by t. Now I can write it as 2 pi 1 by t. What is 1 by t? It is f. So that's why I can write omega as 2 pi f also. Okay, standard formulas. Very, very important. Okay, let's start solving some questions coming up on your screen now. Okay, why is delta used? Why can't we use just write it in t? So Sneha, this is the convention. Like t is used to represent how much time it is from the beginning. From the beginning. When I say t, generally it means how much time is it from the beginning. But delta t means time interval between any 2 points. So that's why we use delta t. So that is a more correct or mathematically correct way of representing these physical terms. I hope that makes sense. So Dhanendra, when is the next lecture? The next lecture I think is tomorrow, bacha, at 7:30. You will always find me over here at 7:30. Some days 11th, some days 12th. So both the classes will go on. In a week, I'll try to have at least 2 to 3 classes at least. Okay, for you guys. Okay. Chalo. Rim. Rim means the outermost part. The outermost part. Okay. Hello Adnan, welcome aboard. Acha, let's try and do this question, guys. Come on, my warriors, figure this out quickly. A point on the rim of the wheel, 2 meters again in diameter, be careful, has velocity of 8 meters per second. So obviously the radius is 1 meter because 2 meters in diameter, and V is given to be 8. So obviously I will use V is equal to omega R. So therefore 8 is equal to omega into 1. Omega will be 8 radian per second, but that's not the answer. The question says in rounds per minute. Rounds per minute. Let me tell you, 2 pi radian is 1 round. 2 pi radian is 1 round. So 8 radian is how many rounds? 2 pi radian is 1 round. So 8 divided by 2 pi. If you divide 8 by 2 pi, you will see how many rounds it has covered. So 8 divided by 2 pi, it is round per second. Now this is per second. I don't want per second, I want round per minute. Okay, so if you want, I'll write it like this. So this is round per second. So if I want to write it as round per minute, in 1 second, these many rounds are over. 1 minute has 60 seconds. So it will have into 60 rounds. I hope you understand this in a minute. So RPM. Okay, now you can simplify this. This will become 4. So 60 into 4 is 240. So this will be 240 divided by pi rounds per minute. Done, done, done. What is omega? Rishabh, I think you missed the first part of the class. Okay, I have taught about what is omega. So please start watching the class right from the beginning. What is omega? Okay. Can we use omega is equal to 2 pi by t? Well, you can use that, but you don't know the time period. You have to find the time period. Only then you can use omega is 2 pi by t. Why is it called omega? Rishabh, why are you called Rishabh? Just think about it, no? So it's like that. Why do you call B as B? Okay, it's something like that. Why do you call velocity as V? Okay, it's something like that. Okay, now what is the time period of the revolution? Well, that is something which you can find out very easily. So you know omega from here. So time period will be 2 pi by omega. I just gave you that formula. So 2 pi by omega, but put it in radian per second. What is radian per second? 8. So this will be pi by 4. So time is pi by 4 seconds. So that's the answer, and this is the answer. Done, done. I hope this is clear. Got it? Okay, Santwan. Do I need to study friction before work power energy because friction is a backlog? Yes, Santwana, you should study friction. Yep, you should. Don't ignore friction because there are questions towards the end in work power energy which might involve work done by friction and all of that. So for that part you will need it. Okay, so that's the answer. Moving on to the next question coming up on your screen. Okay, chalo. Okay, no problem, Rishabh. But yeah, if you still have any doubt, please ask me. I'll be more than happy to help. I'd never get, bothered by the questions you ask, no matter how silly or how, irrelevant it might sound for you. But I am a teacher. My job is to make sure that you guys understand. You guys have queries. That's the job of a student, to ask questions. Fine, you put up questions. I'll definitely answer, but pertaining to the topic, of course. Okay, let's do this. What will be the average acceleration of a car traveling at 36 kilometers per hour? Acha, when it takes a turn by 180 degrees while traveling along the arc of length 314 meter, and what will be the instantaneous value of the same? Interesting. Let's draw the diagram. So I have this car, okay, it's traveling like this with 36 kilometers per hour. 36 kilometers per hour, 36 into 5 by 18, so that's 10. Okay, so that's 10 meters per second. I hope this is clear. Now, okay, yes, motivator, I'll be giving the PDF as well. Yep, it is 10 meters per second. It turns by 180 degrees. So if it turns by 180 degrees, that means the new velocity will be here, and that will be 10 meters per second. Great. And how much is the length of the arc? 314 meters. Interesting. So the length of the arc is nothing but 314 meters. And I'm pretty sure there will be some radius as well. Okay, I don't know the radius. Maybe we'll find it out later on if needed at all. But okay. Now, the question is, how much is the average acceleration? I'll tell you what. Average acceleration, go by the definition. Average acceleration, normal, go to 1D, 2D. We have studied this long time back. It is nothing but change in velocity upon time. Now, a lot of people might think, sir, velocity was 10, now it is 10, 10 minus 10, 0. Oh, no, bacha. It is not like that. Okay, let's say we are interested in the magnitude of this. See, change in velocity is final minus initial velocity. Now, if you notice carefully, the final velocity is minus 10. Be careful about it. It is minus 10. Minus initial velocity is plus 10. Do you see that? It is plus 10. It is towards the right side. And the time taken, acha, I don't know. I'll figure that out. But minus 10 minus 10, that will be minus 20. So the total value on the top will be just 20 because I'm taking modulus. Is that clear? Is that clear? Yep. Now, no, you cannot do all the problems of physics mentally, of course. Now, the only problem is time. I don't know the time. So I think I'll have to do something. Acha, the distance traveled, the distance of the semicircle, okay, the semicircle, the distance which it travels will be the speed, okay, multiplied by that time. How much speed it is traveling with into the time. What is the distance? It's mentioned 314. Okay, so 314 is equal to velocity. Well, that velocity is 10 into delta t. Now, here is what we can do. If you don't like this number 314, even I don't like it, trust me, you can write this as 3.14 into 100 is equal to 10 delta t. What is this 3.14, guys? It is pi, right? It's just pi. So pi, one of the zeros get cancelled, and into 10 is equal to delta t. So now this looks simple. This looks more nice and compact. So let's put delta t over here as 10 pi. So the moment you put over here as 10 pi, one of the 0 goes, and you will have this as 2 by pi. That's the value of the average acceleration. Yep. Excellent. So I'm interested only in the modulus. Remember that? I'm only interested in the modulus. So that's why the magnitude will be 2 by pi. That's it. Perfect. I hope this is clear. Yep. Yeah. So can theory of friction suffice? No. You have to solve problems, Santvana. You have time. You are in 11th standard. Don't hurry up. Lot of teachers and lot of institutes might fool you into saying, skip a chapter, do it later on. Work for energy, do it right now. They are fooling you. They are playing with your life. I am not the teacher who is going to play with your life. Guys, you have time. See, there are students in 12th standard who have missed their 11th standard portions. Just think about them. Bacha, at least you are not in that position. You have time. Make use of this time. Cover your backlogs. Don't run after one shots. One shots will screw with your mind. You will probably miss 100 concepts out of that. So try to do that hard work, and whatever extra time is needed, stay awake. Sacrifice something, get that time, and then try to cover it up, bacha. But don't leave that chapter. Okay, chalo. Let's get going to the next part. What is the next part? What is the instantaneous acceleration? Okay, instantaneous acceleration is simple. Instantaneous acceleration will be just the centripetal acceleration because it is turning, right? So you just need to find the centripetal acceleration. And what will be the centripetal acceleration? It will be v square by r. Do I know the velocity? Yes, it is nothing but 10. So 10 square. Oh, but the radius I do not know. What do I do? Look at this. 314, guys. What is 314? 314 is the semicircle's length. So I can say 3.14 into 100 is equal to pi r, correct? Pi r, 2 pi r is complete circumference. Pi r is the length of the semicircle. 3.14 pi gets cancelled. So r is 100 meter. I got this. So just put 100 over here. Now you will get the answer. What is it? It is 1 meter per second square. Done, done, done. Yes, it is not 0. It is not 0. Yeah. I hope this is understood. So now what do you get from this problem? See, this car which was going, okay, like this, then turns, then turns, then turns, then turns, then turns. These were the velocities. The acceleration is always towards the center. This is the centripetal acceleration. The value of that centripetal acceleration is 1 meter per second square. But the average value in 2D is 2 by pi. That's what it means. So they are two different things. They are two different things. Understand that. This value I have obtained by v square by r, which is centripetal acceleration, because I know the car is only changing direction. So it should only have centripetal acceleration. But on an average, the direction of centripetal is also changing. So for that, I used the basic definition of average acceleration. I hope this is clear. Selva Kumar, it is clearly mentioned 180 degrees. 180 degrees. So that's why pi r. What is the length of semicircle, bacha? The length of a semicircle is pi r, right? Kamlesh. Hi Ria, welcome. Yep. If you start from today also, motivator, definitely you can crack, bacha. It's not too late, but start today. Don't start tomorrow. Start right now. Now, this is your homework question. Angular displacement of the particle is given. What is the angular velocity? Put it up in the comment section. The particle moves in a circle. What is the centripetal acceleration? What is the angular velocity? And what is the next question is, what is the frequency? What is if the particle is moving in a circle of radius 100 meters and all of that. So try to do this. Yeah, post up all the answers in the comment section. I'll be showing all the people who did the homework. And let me show you this very important thing. Guys, if you're watching the video right now, and if you are interested in my batches, if you're interested in my courses, and if you want teachers like me, and if you feel your coaching is not doing justice for all the effort that you are willing to put in, Sometimes, it happens that you join the wrong coaching, or maybe you didn't join the coaching and you feel cheated, or you feel that need for some mentorship. So please don't hesitate to take that mentorship. And Vedantu is one of the cheapest and the best online platforms. Even if you compare it with offline, it's one of the best platforms. I have been teaching in offline platforms, before this, in all the reputed institutes that you can ever think of, and I know what's the difference. And I know what happens in offline coaching institutes. There are many good offline institutes, undoubtedly. But guys, if you feel that your center might not be doing well, or maybe your teachers are not helping you out, then please consider joining Vedantu. There is a link in the description box. There is a CBSE batch, and there is also a 2-year JEE batch. So if you click on the 2-year JEE batch, this is what you will get. You will get the complete course with topic specific short courses like KVPY, problem solving, book solving, revision towards the end of the syllabus, and any other course that will come on the way. This is mains and advanced both together, and you will get the recordings, test series, you will get the report cards, obviously, you will get assignments after every class. That's very important, solving questions. And a lot of people keep asking me, sir, give me more problems. So that's where you will get the assignments from. Doubt solving. During the class, there are 2 teachers. Apart from the main teacher, there is another teacher solving your doubts. And you will also get doubt solving on the mobile app. Okay, that's in the classic version. And in the plus version, you will get personal mentorship. Now, most of the students I know will go for either light or classic. Students who go for light, they feel that need for doubt solving, eventually come to classic. So you will see classic is the best option that you can try. But if you need the personal mentorship, then go for the plus version. This price is the 2-year price. It's not 1-year price. Even if you want to try it out for 1 month, that option is there. And after 1 month, you just have to pay the remaining fees. You don't have to pay again the same fees. That also is something which you should note. You also have option of EMI over here. 3,000 rupees, 3,300 rupees, and this though is even more cheaper. So hardly any difference, guys. Hardly 300 rupees difference. You get the classic version, like you can see over here. Okay, so that's something which I feel that you personally should get yourself enrolled into, and the batches start on Monday. Let me tell you that. Yeah. So basically, we do not give sums on Telegram, bacha. We give the PDF of today's session along with the assignment. So the assignment is basically whatever questions I gave you as homework, plus any extra information that comes, I'll post on Telegram. Second thing, if you want more questions, please join the pro subscription. That's where you will get the assignments, the modules, the booklets, and all of that. So what's my dinner at home, Selva Kumar? I think it is some kind of beans and some kind of dal. Yeah, I guess. So what is the unit of centripetal? It is meters per second square, Kamlesh. Yep. When will I finish? By next week I'll finish, Lily. This session will be over. Tomorrow is the second class. Next class will be on Monday or Tuesday. So by Monday or Tuesday, this class will be over. This chapter will be over. Is that okay, bacha? All right. So can we pay monthly installment? Yes, Dharmendra, you can even pay monthly installment 3,300 roughly, or 3,000 rupees per month for the next 2 years. That's an option available. 0% interest. So in fact, if I was a student or if I was a parent, I would obviously opt for EMI. Unless I have that money, I would definitely put in one go. Either option is fine. Okay, the next chapter, Anil, will be center of mass. Yeah. KIT CSC, can you put up the full form, Safari? That would be better. Oh, Selva Kumar, dosa is my favorite too, but I generally don't eat dosas in the night. I prefer eating dosas in the morning. I love dosas, masala dosas, set dosas, utthapas. I love it. It's my favorite too. Okay, khichdi. Wow, Kavita, nice. Okay, I hope you guys are well, but Kavita, because khichdi generally people are not well, and that's when people eat khichdi. Sorry to ask, sir, but how can we study physics easier? Because it gets difficult to me when it comes to calculation. Sneha, you should love numbers. I'll tell you something. Whenever you go to a shopkeeper, right? Don't use calculator or your phone or anything. Try to calculate it mentally. Also, when you're sleeping, try to say all the tables from 1 to 30. Yeah, 1 to 30. Squares, square roots. And when you're sitting, I say randomly, instead of playing some games, try to do mental math. Trust me, you'll start loving numbers within no time. It will take some time, but you will start loving it. Just do that. You should have that love for numbers. Okay, so oops, oh, that's not true. Oh, is it? Okay, my bad, Siddhi. Sorry for stereotyping, guys. But yeah, khichdi is nice if you make it very nicely. I don't know, many people feel khichdi is not that great, but the khichdi that I have at home is very nice for sure. What is basic physics? Basic physics has, Ashwini, all the basic concepts like the 9th to 11th moving kids need that additional push before entering 11th. Some mathematical terms are there, some physics terms are there. So to make them understand the new things which they will see. So just to make them habituated to this kind of learning, we have basic maths and basic physics. Okay. Oh, that's a myth. Okay, fine. Siddhi, I'm pretty sure you have good khichdis and good, what is it called? Sabudana also. I have seen this happens, you know, a lot of injustice also happens to sabudana. The moment you eat sabudana, are you not well? Are you fasting? I'm like, no, I'm not fasting. I love sabudana. It's so nice to have sabudana. Don't you guys agree with that? Now you guys are making me hungry, and salads are good for dinner and even healthy. That's very true, Sneha. But right now I'm in no mood for salads. You guys have made me really hungry. I'm going to hog onto my dinner plate. I can't wait. I'm starving now. Okay, take care, guys. Have a great time. See you again. This was Captain Shreyas, and I was going live. Hasta la vista.